Hey guys, I'm going to get started with your 11-2 day 1 video. I'm going to jump straight to the examples, go through them as fairly quickly and explain quickly if I can. So for this first one, I'm going to jump right to the question. It says, which of the following is the component of the chi-squared statistic corresponding to the category at most -2? So when you look here and remember that formula is on your formula sheet on how to do the chi-squared test statistic, and it's where you take your observed count, 18, subtract your expected count, square, and divide by the expected count. So that would give us an answer of D. For example 2, this is where you might need to pause. It asks you to fill in the rest of your expected counts of this table. So you'll want to pause this and take a look and compare. Right here is the calculation and how you find your expected counts. For example 3, I'm going to again go straight to the question. It says, is there evidence of a difference in cafeteria food satisfaction among the class levels? So what you should notice is that now for 11-2, we're looking at a two-way table. There's two different categories. We're looking at, in this case, class level, and we're also looking at are they satisfied or are they dissatisfied? So if you look at your notes, you'll see right above this example, there is a demonstration of how to plug this into the calculator to run your chi-squared test when you're working with your two-way table, where you use the matrices. So if you go ahead and you run that test, and like I said, you'll see that all kind of typed out for you in your notes, you'll find that you'll get a p-value of 0.1117, which would then tell you there's not evidence of a difference in the food satisfaction. Okay, let's move on to class notes. So this is just a quick reminder from your reading for the hypothesis and the difference between the chi-squared goodness of fit and the chi-squared homogeneity test. So the null hypothesis and the claim is that there's no difference in your categorical variables for several populations, and then the alternative would be that there is a difference. So you'll notice you're claiming that whatever you have is there's no difference. That's what the homogeneity means. And then the alternative is that you have evidence to prove that there is a difference. Okay, so let's look at the first example. So we're looking at a study of a European restaurant when they are comparing no music, French accordion music, and Italian string music. And the question is there convincing evidence that background music influences what people buy? This term right here, convincing evidence, is what's telling us we're going to run a test. So we're going to go through that state plan, do conclude. So what does the state look like here? Since we are working with a two-way situation, we're talking about the treatments of music and then what people buy. So we claim that there is no difference in the distribution of entrees chosen that are ordered at this restaurant when no music is playing, French accordion music or Italian style, which then means the alternative is that there just is a difference. So they're essentially the same thing, just the alternative is a difference and then the null has no difference. Okay, so what we're going to do next is plan. We will do a chi-square test with a degree of freedom. How you calculate the degree of freedom that is different from 11-1 is that since we have now two categories, you still do the category -1, but this time, since you have two of them, you're going to take the category -1 and then take the product of the two. So since we have three different entrees we're looking at, -1, and then three different styles of music, -1, that's 2 times 2, which gives us 4. And again, when the significance level is not given, we assume a significance level of 0.05. Then you go through the conditions, which you'll see in your reading were listed out for you. We know that it's an assignment of random treatment because that's what it said. The 10% rule doesn't apply here because these are independent, and then the expected values are all greater than 5. So again, if this was on a test, you would need to show all of your expected values or list them, that they are greater than 5. So next, we are going to move on to the do. So I've popped up these two graphs for you so you can look at what I'm plugging in here. I have clippings of the calculator, so they're all going to pop up together here. You're going to use the matrices when you have the two-way table. So again, we're looking at the French and the Italian and the other type of entree versus the type of music. Okay? So we are creating an observed matrice and then an expected matrice. So that's kind of what I clipped here for you. So you go into your matrice and you calculate it. This is a 3 by 3 since we have 3 rows, 3 columns. fill in matrix A. You just need to remember which one you made the observed and which one you made the expected. So my A is my observed counts, my B is my expected counts. And then once you do that, then you're going to go into your test, and you're going to now, the difference from yesterday is you're going to run a chi-squared test. This is the one that is for homogeneity. So when you're working with your two-way table. Once you figure that out, go into your observed, put in matrix A, expected is matrix B, and then you're going to calculate. And what you'll find is your test statistic is 18.28 and your p-value is 0.001. So again, to answer the question, you use the p-value. Since our p-value is less than our significance level, we are going to reject the null. Okay, so rejecting the null means we have convincing evidence that there is a difference in the distribution of entrees ordered at the restaurant when no music, French music, or Italian string music is played. So the random assignment allows us to say that the difference is caused by the music that is played, because since it was a random assignment, that means that what affected the choice of the food was the music that was playing in the background. Okay, so part B says interpret the p-value from the calculator in context. So again, interpreting the p-value is basically stating what does that 0.0011 represent. So again, whenever you interpret a p-value, you have to assume that the null is true. You assume the claim is true to be able to make a judgment call. So we are saying, assuming that there's no difference in the entree choices when no music, French music, or Italian music is played, there's a 0.0011 probability of observing a difference. So that p-value is observing the what would be called like the extreme, the alternative, the difference in distributions among the three treatment groups. So then our last one here is a follow-up. So this is all typed out for you. I'm just kind of showing you how to look through this computer output. So this, like I said, is all typed out. So it's saying, looking at this output, what we can see is that 2, so this is in the order in which it is in your table in your notes. So if you refer to part A up there under entrees ordered, it says French, Italian, other. So number 1 is French, number 2 is Italian, and then number 3 is other when we're talking about entrees. None, French, and Italian is your music style. And then right here is the data that we're looking at. So looking at the chi-square test statistic right here is 7.672, and then this one is 6.404. That's about 14 of our chi-squared test statistic, which was 18, which means that's a lot of that test statistic is made up just between those two. So that can give us a more specific conclusion saying that Italian entrees, so again, here's our Italian entree, because that is number 2, is strongly affected by Italian and French music, because this is the French and this is the Italian music. Number 2 represents Italian entrees. So since these two chi-square test statistics make up about 14 of the 18.28, that's a whole lot. So those are strongly affected by that music that is being played.